Okay, so the first thing we want to do whenever we want to solve an inequality is basically the same thing we do when we have an equation. We want to simplify everything by removing parentheses and combining like terms. So in order to remove the parentheses over here, the first thing I'm going to do is use my distributive property and multiply everything by 2, which will give me 2 times 3, which is 6. Minus 4x plus the 5x. That's all on the left side. And we're leaving this less than or equal to. And then we have a negative in front of the parentheses. And there's no number. But when there's no number, there's just a sign. It's as if there's a negative 1 there. We're going to multiply everything in this parentheses by negative 1. So negative 1 times negative 2x will give us positive 2x, and negative 1 times negative 3 will give us positive 3. So already things look simpler. The next thing we want to do is see, is there anything that we can combine? And I see over on this left side, I have a negative 4x plus a 5x being like terms. So I'll leave the 6 alone. Combining the negative 4x and the 5x will just give me a 1x or just an x. So now we have 6 plus x less than or equal to 2x plus 3. The next thing we want to do is make sure to get, because it's an inequality, we want to make sure to get all the x's on the left side, all the numbers on the right side. So I want to get rid of this 2x over here. So I'm going to subtract 2x from both sides. And I want to get rid of the 6 that's on this side. So I'm going to subtract 6 from both sides. Alternatively, I could use what we call the method of moving things from one side to the other by just changing their signs. What we call the transposing method. I bring the 2x to this side, so it'll become a negative 2x. I'll bring the 6 to this side, so it'll become a negative 6. In any case, what we're left with here is on the left side, the positive x and the negative 2x, which gives me a negative 1x or a negative x. Notice I always leave the direction of the inequality the same when I'm moving things from one side to the other. Here, the x, 2x and negative cancel out. And now I have 3 and negative 6, which is negative 3. And I'm almost done. I just have to make sure that I have just a plain x on this side. So I have to divide by the coefficient of the x, which in this case is a negative 1. Negative x is the same as negative 1x. So I will divide both sides by negative 1. Now here's the one case I have to be very, very careful about. Whenever I am dividing by a negative number, which we are in this case, I have to change this, what we call the sense or the direction of the inequality. So in this case, I'll get the negative x divided by the negative 1, which will give me here, let's go over here, x. The negative 3 divided by the negative 1 will give me 3. But since it was originally a less than or equal to, this will become a greater than or equal to. In other words, my answer turns out to be x greater than or equal to 3. Let me see, is that? I see. Here is the one place, don't forget when you're dividing by a negative number that you are when you divide that you have to change the direction of the inequality. Now, what does this look like on the number line? Well, to write x greater than or equal to 3, I have to go to the 3 on the number line, which is right here. And I have to put a filled in circle on the 3 because it says x greater than or equal to 3. And since this arrow is pointing to the right, I will draw an arrow from the 3 to the right. That is what the answer would look like on the number line. In interval notation, remember when you're writing the interval, you just write the numbers. On the left side of the interval notation, you put the number that's the furthest to the left of the section that is covered in the number line, which is the 3. On the right, you put the number that's all the way to the right. Well, in this case, the arrow is pointing all the way to the right without stop, which means that's the number we call infinity. Infinity means it's just going on and on. Since the 3 is a filled in circle, because it was greater than or equal to 3, we put a bracket by the 3. By the infinity, we always put, whether it's a positive infinity or a negative infinity, it always gets a parentheses. Are there any questions about this problem? Anybody have any questions about this? Don't forget, this is very important, that when you are dividing by a negative number, that you switch the direction of your inequality.
I have a question.
Sure, please, I'd love to answer a question. Who's
Renee?
It's Kizia, that's who's,
No, it's
Oh,
Renee.
no,
who's
Renee
speaking.
had a question first.
okay, I just don't hear, go ahead, ask your question, please.
Okay, so I put, instead of subtracting 6, I subtracted 3 from both sides, and I subtracted, so I got 6 minus 3, and then I did x minus x on both sides, and I got positive 3 greater than or equal to x. So my number was, my sign was different than the original answer.
Wait, okay, I'm gonna go back to where you're, can I erase this, everybody? Oh, you know what, let me erase this part, because this we don't need. Well, what you did, okay, let me go back to here. You're over here, right? From this, I assume we're at this point, right?
Yeah.
And you brought the 3 to this side.
Mm-hmm.
Did you just bring it over, or did you do minus 3 from both?
Minus 3 for both of them.
Okay. And you did minus x also?
Yes.
Okay. So 6 minus 3 gave you 3. This canceled out. This gave you less than or equal to x. And this canceled out, right?
Yeah.
This is what you were left with.
Yes.
What does yours say? Yours says 3 is less than or equal to x. Now, the problem with this is that when you want to go to the number line, or when you want to go into the interval notation, you really have to have the x on the left side and the number on the right side. So let's see if we can understand what this says. This is saying 3 is less than or equal to x. Isn't that the same as saying x is greater than or equal to 3? If I'm turning this around to put the x on the left side, I have to turn around your inequality sign as well. 3 To say 3 is less than or equal to X is equivalent to saying X is greater than or equal to 3. Are you following me?
Yes.
And notice then you've got exactly the same thing that we did. So your problem was not how you solved it. This was correct. Your problem was how did you interpret it from here? And it's very hard. That's why I keep saying, what you always want to do is end up with your X's, even though it means a little bit extra work. You really want to always have your X on the left side and your number on the right side, so that when you read it, it reads correctly, because this looks like the arrow should be going to the left, but it's not. It's here's the X. You always read from the X. This is telling you the X is bigger than the 3. Okay, now somebody else had a question.
Oh, no, I had the same question as Renee. I did the same thing.
Okay.
But I understand.
Do you understand why now? Okay, should we do one more like this?
Yeah.
Should we try another one just well, I'm going to put another one on the board, and I'm going to ask, then I'm going to, as you're doing that one, I will take attendance, and then we'll go over that next one, just again, to make sure we're clear on this, because those little mistakes can mean the difference between getting the question right. Here, you do all the hard work correctly, because that was the hard work, was getting it was just then making sure that you understand what your answer means. Okay, so here's the next problem that we're doing. It doesn't have as many parentheses, but I want to make sure that you understand the interval notation and the graphing part. So again, solve it, then put it in on the number line, and also put an interval notation. Again, while you're doing that, I'm going to be reading attendance. So you're going to have to be double listening for your name at the same time you're doing the problem. Maury, elaborate. Maury? Chelsea Asamoto. Asamota?
Here.
Okay, great. Ariana Baptiste.
Here.
Good. Adina Blenman.
I'm here.
Good. Please make sure if I'm not pronouncing your name correctly that you let me know. Lachey Boucher.
Here. I'm here. It's voucher.
Boucher. Oh, okay. I was trying to say it the way it looks like a French name. It's by the way, I probably will start just calling you by your first names because it's just easier. If somebody wants to be called by their last name, please let me know. Tamia Brown. Tamia? Tamia here? Kava Collingwood. Kava, you're here? Good. Good. Terrence Cruz? Terrence?
I'm here.
Good. Okay. Oluwakorede Dabiri.
Here.
Can I go, how do you pronounce your name?
Olua Kuride or just Kuride.
Karide. Okay, that's what I'm gonna call you if you don't mind.
That's fine.
Okay, thank you. Kizia Daniel.
It's Kezia Daniel. I'm here.
Good. Faith Diggs. Faith here. Ethan Elson. Ethan,
Here.
good. Isabella Enriquez.
Here, it's Enriquez.
Enrique, okay. Thank you, Isabella. Serenity Garrett.
Here.
Okay, good. Reggie Gomez. Reggie. Zamia Grady. Zamia. Brandon Hernandez.
Here.
Good. Makala Martin.
And it's Michaela.
Michaela, okay. Seraphine Nurse. Seraphine,
I'm here.
good. Marissa Paris, Marissa,
Here. It's just Paris.
okay. Were you here on last Thursday? Because I don't have you here.
No, I wasn't here.
Okay, this is your first time. Okay, welcome. Renee Peters Holder.
Here.
Hi, how are you? Is it Renee?
Yes.
Okay. Sky Powell. Sky. Jaden Roberts. Jaden. Kennedy Shelton. Kennedy Shelton.
Here.
Oh, okay, good. Felicia Simon. Felicia Simon.
It's just Felicia. And I'm here.
What? I'm sorry.
Felicia? Yeah, it's Felicia Simon.
You're not coming clear out of your.
Can you hear me?
Now I can hear you. What did you say?
Yes, it's Felicia Simon.
Felicia.
Yes.
Uh, Natalia Small.
Here.
Okay, good. Michael Todd,
Here.
good. I also have you absent on Thursday. Were you absent on Thursday?
Yes, I went to the funeral.
You were here?
No, I wasn't.
Okay. All right. Welcome to the class today. Cassidy Tucker. Cassidy Tucker. Megan Vanzi. Megan Vanzi.
Here.
Good. Kalia Watson. Kalia Watson. Lauren Whaley.
Here.
Good. Kayla Zakari.
Here. It's Kayla Zachary.
I'm sorry, I can't hear what you're saying.
Here. It's Kayla Zachary.
It's Kayla Zachary?
Yeah.
Okay. Thank you. Lauren, I just wanted to, Lauren,
Yes.
I saw that you had signed up 2 different times on the Delta Math.
I did.
Yeah, should I just get rid of the one that you don't seem to be using? I think one was, it was 2 different email addresses that you used. Or can you go on and just get rid of the one you don't want?
Okay, because I know I completed the homework on one.
I'm sorry, the homework?
I know, like, the homework, I did it on one. I only thought I had one account.
Right. I saw that the homework was done on one of them and not on the other. So I can just get rid of that one, or you can get rid of that one that's not being used.
Okay.
Okay, so I'll look. If you get rid of it, fine. If not, I'll just delete it. Okay. Did everybody get a chance? Let's see. Let me see what my chats. Okay, I see that Terrence has an answer. A few people have answers. I even see some people put the answer in interval notation. So let's do this together, and then we'll go on from there to some newer work. Okay, so again, on this one, I always want to end up with the x's when it's an inequality. If you really want to make sure that you're getting everything correct, you really want to end up with the x's on the left side and the numbers on the right side. It's not so important on an equation, but in an inequality, it really is. So in order to do that, I'm going to add 4x to both sides, so that there are no x's left on the right side. And I'm going to subtract 21 from both sides, so that I'm not left with any numbers on the left side. So in the end, I'll have all the x's on the left side, all the numbers on the right side. So here I have negative 7x plus 4x, which gives me negative 3x, greater than or equal, because I don't change it when I'm moving things from one side to the other. I always leave the inequality in the same order. And here I have a negative 9 and a negative 21, which is a negative 30. Okay, so then my next step is I've got to get the x's alone. Now this is a negative 3x. So what I am going to have to do is to divide by negative 3 on both sides, so that I get x by itself. But remember, again, here's a case. I'm dividing by a negative number. Only when I divide or multiply by a negative number do I do anything with the direction of the inequality. If I were dividing by a positive number, I'd leave the sense or the direction of the inequality the same. So this is now going to be switched to x less than or equal to negative 30 divided by negative 3 is 10. So this is what your answer should have been in as a inequality, x less than or equal to 10. And I see that most people who did that problem, that's the answers everybody is giving me. So that's great. Okay, but we're not finished because we don't have it on the number line and we don't have it in interval notation. So let's first draw this on the number line. So here's my number line. Here's my 0. And I have to go to 10. So let's say 10 is over here. This is telling me that x is less than or equal to 10, which means that at 10, I'm going to have to put in a filled in circle because it says less than or equal to, and my arrow has to point to the left. If you were doing this on Delta Math, if and you're trying to draw the number line on Delta Math, let me just mention, what you do is you take your cursor and put it on the 10, and then drag it in the direction you want to go. In this case, you'd have to drag it to the left, and you'll see it'll draw a line. It automatically makes a filled-in circle. If you don't want a filled-in circle, if you want an open circle, because this is just saying, let's say a less than, then you have to click on this dot, and it goes from a solid dot to a open dot. So that's how you would do it on Delta Math. This is the way it graphs on the number line. In interval notation, what we need to do is put the number that's all the way at the left on the left side of the interval, the number on the right, all the way on the right. Now this is the arrow is pointing all the way to the left. So the beginning of the interval, which is on the left side, is all the way over here, which is negative infinity. The end of the interval is the point that's on the right, happens to be the 10. At the infinity point, we always put a parentheses, whether it's a negative infinity or a positive infinity. Infinity never gets a bracket. Infinity is always a parentheses. The 10 being a filled-in circle, meaning the 10 is included, that's what we put our bracket. So in an interval notation, I get negative infinity, comma, 10 brackets. Is there any further questions about this? Okay. So that seems that those are how we solve and give our solutions to inequalities. Okay, I'd like to go on from here and talk about something called a compound inequality. What does a compound inequality mean? I'm going to start with a very simple compound inequality. We're going to try and explain what it means. And after that, I'm going to show you how to solve examples that involve compound inequality. The word compound, it's like a compound sentence. A compound sentence is a sentence that tells you two ideas. Usually when you have a compound sentence, you have two sentences that are connected with a word like and or. We're going to talk about compound sentences in inequalities that are going to be connected by the word and. In other words, I could say something like, I am going to the store and I am buying Coke. I'm telling you two things. I'm telling you I'm doing two things. And that statement is only correct if both things are true at the same time. I am going to the store, I have to go to the store, and I have to buy the Coke. If I go to a vending machine and I don't go to the store, that statement is not true. I might have bought the Coke, but I didn't go to the store. If I went to the store and I bought Pepsi and I didn't buy Coke, that statement is also incorrect. In other words, for an and situation to be correct, the compound situation to be correct or true, both of the statements have to be true. So I could write an inequality that looks like this. This is an example of what's called a compound inequality. It's really a strange thing to write because I'm writing two inequality signs. When I write an equation, I don't write two equal signs. How can I do this with an inequality? Well, really what I'm trying to say, this is a shorthand way of writing this statement. -1 is less than or equal to x. And also, x is less than 8. That's what this is. In order to, it's just, instead of having to put the x twice, we just put the x in the middle and we put the two inequality signs, one on either side of the x. And really, we read this from the middle. X is greater than or equal to -1, and x is less than 8. This double inequality, this compound inequality, always means two inequalities that are connected by the and. Now, if you look at this -1 is less than or equal to x, remember I always told you I want the x to be on the left side. -1 less than or equal to x is equivalent to saying x is greater than or equal to -1. If we're turning this thing around, then the smaller number is the -1, the larger number is the x, so we have to write the x greater than or equal to -1. So this is saying x is greater than or equal to -1, and also at the same time, x is less than 8. That's what this is saying. In shortened version, this is saying this. What does that mean? Let's look at it on a number line. Here's what it means on the number line. First, x greater than or equal to -1 means, here's my -1. It means a filled in circle at -1 and an arrow pointing to the right. X less than 8 means, here's my 8, let's say. It means an open circle at 8 and an arrow pointing to the left. Now you have to understand, there's an and between these two statements. And means they're both occurring at the same time. It's not enough that my x has to be greater than negative or equal to -1. It's not enough that my x has to be less than 8. It has to be both of them at the same time, which means where these two lines cross, this area here is the only thing that is doing both this and this. So essentially, I'm going to make it look much simpler. Essentially, to write this double inequality where you have -1 less than or equal to x less than or equal to 8 means you're talking on the number line, the interval that starts at -1 and goes until 8. It doesn't include anything to the left of -1. It doesn't include anything that's to the right of 8. It's simply between the -1 and 8. And you know what? That's what this actually looks like. Look at the x. The x is between the -1 and the 8. That's why we actually use this symbolism, because it really is telling us what to look at. It's easy to understand without doing this whole long thing. This really, I could understand this right away from this. So when I use this double inequality, what I'm really telling you to do is to look on your number line. Look at how this compares. I'm just going to compare this to this. How this looks like just putting it on a number line, and this section that's filled in is where the x is. You put the -1 on the number line, you put the 8 on the number line, and everything in between, that's where your x can be. Your x, we could read this as x is between -1 and 8. Now, when you're doing this compound inequality, this double inequality, there are certain things you have to follow. First of all, because you want this to be in the order of the number line, you always put the smaller number on the left side, the larger number on the right side, because that's how your number line goes. And your inequalities then will always be less than inequalities. In interval notation, it's even easier to write. Remember when we write interval notation, we write the smaller number on the left side, which in this case is -1. That's the start of the interval. The end of the interval, the number on the right, is the 8. So I just put in the numbers. Since at the -1 we had a filled-in circle, we make it a bracket. But at the 8 we only had a open circle, so that's a parentheses. So if you look at this, when you compare the inequality with the interval, all you've done is left out the x. And you put in these symbols, the parentheses, where there's a less than or equal to, you put a bracket. Where there's a less than, you put a parentheses. So the interval notation, the inequality, and the number line all sort of match. So what looks like a very long, right, that's exactly, Adina, that was beautiful. She explained it very much. The inequality, this compound inequality, is not going all the way to infinity. It's just going between -1 and 8. It's limiting, yes, it starts at the number -1 and it ends at 8. That was very good. That was a good way of putting it also. Now, what does that mean for us? How do we solve these compound inequalities? So let me give you an example of a compound inequality, and I'll show you how we can go about solving this. Suppose I had an example that looked like this. 9 is less than 3x minus 6 is less than or equal to 15. This is certainly of the same type of compound inequality that I was talking about because it is two inequalities in one. So that makes it compound. The number on the left side is smaller than the number on the right side, and the signs are less than. That's what you must always have when you want to do this compound inequality. If it's written in a different way, it's not correct. It has to be written like this. Smaller number on the left, larger number on the right, less than. But also, when we want to solve something like that, we don't want to have some complicated thing in the middle here. What we want in the middle is just a plain X. So how do we go about solving this? Now, I could show you a complicated way of doing it by separating them and taking it apart and then solving it, but I'm going to show you an easy way to do it. We want to be left with, in the middle, just a plain X. And we want a smaller number on the left and a larger number on the right. That'll be my compound inequality. So I concentrate what's on the middle. So remember, I want to get the middle to be just a plain X. So the first thing I want to do is get rid of this -6 here. So I'm going to add 6 to this middle. Now, really think about it. I'm doing two things at once. So if I add 6 to the middle, I have to add 6 on the right side, but I also have to add 6 on the left side because I'm really doing two problems at once. I'm doing the problem where I have 9 less than 3x minus 6, and I'm doing the problem where I have 3x minus 6 less than 15. I'm doing them simultaneously. I'm doing two problems at the same time. Okay, so whatever I do in the middle, I do the same at either end, at both ends. So here I do 9 plus 6, and that gives me 15. Here the 6x cancels out, so I have a 3x in the middle. And here I have 15 plus 6, that gives me 21. Notice these were less than signs, so I just carried down the less than signs, because when I add something, I don't change the direction. The next thing I have to do, I have a 3x in the middle, so I don't want a 3x in the middle, I want just a plain x in the middle, so I have to divide by 3. But if I divide by 3 in the middle, I have to divide by 3 on either end. Whatever I do at the middle, I do it on the left side and on the right side as well. So now I'm left with 15 divided by 3, which is 5. Notice I divided by a positive number, so I don't change the direction of the inequality. It still stays less than. Then I have 3x divided by 3, which is x. And then I have 21 divided by 3, and that becomes less than 7. Again, I divided by a positive number, so I leave the direction. I now have my compound inequality in its simplest form. I can now, this is the solution as an inequality. On the number line, it looks like this. Here's my 0. 1, 2, 3, 4, 5 is here. 6, 7 is here. These are both less than, so I make open circles at both of them. And remember, this is equivalent to saying x is between 5 and 7. I just fill in the area on the number line, the interval on the number line that's between these two numbers, which means in interval notation, it's 5, 7 with parentheses because these are open circles. Notice it's easy to solve and easy to graph and easy to write in interval notation. If you just do whatever you do in the middle, you do at either end and make sure that you end up with just a plain X in the middle. Is there any question about this? If not, I'm going to give you one to try. Okay, let's give you one to try. Okay, this says -12 is less than or equal to 2x plus 6, which is less than or equal to 10. If you notice, sometimes either both less than, sometimes they're both less than or equal to, and sometimes one is a less than or equal to and one is just a less than. It doesn't matter. It could be any combination as long as they are less than. They're not greater than signs. They're always less than, because the smaller number always has to be on the left side and the larger number has to be on the right side. Okay, I'm giving you a few minutes to try this. Again, solve it, put it in interval, put it on the number line and an interval notation. That was quick. Okay, see, a few people are already coming up with the answers and they're doing it in interval notation, which is obviously the easiest way to give the answer on when you're doing the chat, because it just, again, you could just type it from your regular keyboard. Again, and okay, so I see, is anybody wants more time? Okay, I see a bunch of people giving me answers. So let's just do it together. Again, it's a compound inequality because we know we have the smaller number on the left, the larger number on the right, and these are less than signs. And we want to end up with just a plain X in the middle. So the first thing I'm going to do is I'm going to get rid of this +6 by doing -6 from the middle, which means I have to do it from either end as well. Whatever I do in the middle, I do at either end. So -12 and -6 is -18. This stays less than or equal to. The 6's I've gotten rid of, so this is just a 2x. And this is less than or equal to 10 minus 6, which is 4. And now I divide by 2 because I want to get the x by itself. Again, I always look at the middle to know what to do. But whatever I do in the middle, I do at either end, on the right side and on the left side. And again, I'm dividing by a positive number, so this is going to give me -9 over here. This stays less than or equal to, here's my x, because 2x divided by 2 is x, and this is less than or equal to 2. And here's your answer as an inequality. On your number line, it looks like this. Here's your -9 is over here. Your 2 is over here. These are both going to be filled in circles because these are less than or equal sign, and it's everything in between. In other words, once you've found the two numbers, you just fill in the interval on the number line that's between them, which means that your interval starts at -9, it ends at 2, and these are both brackets because these are the -9 and the 2 are included in the interval. Okay, so that's how we solve a compound inequality. It's relatively simple. That's why it's set up as a double inequality, because it makes it easier to understand and easier to work with. Okay, I am now going to go on to one other topic, and that topic is where we're going to start it today, and we're going to go on from there on Thursday. Let me just mention before I go on that next week we only have class on Thursday. School is closed. There are no classes on Monday, Tuesday, or Wednesday. So we only will meet next Thursday. I will probably on Thursday, I'll probably send you an email telling you what to do for homework for the following week. But we will be continuing with our discussion of inequalities, etc. After we finish today's discussion, as I said, we're going to continue it on Thursday. We will then be going on to graphing of linear equations, graphing on the X and Y axis. So if you bring some graph paper, that will be helpful for you. Okay, let me erase this and we'll go on from here. Again, anytime you have something that you'd like to ask me, or you can either put it on the chat or you can just ask it, just unmute yourself and ask it, whichever works better for you. Okay, we're going to be talking, in the next topic we're talking about is something called absolute value equation. Okay, so before I do absolute value equations, let me just talk about what do we mean by an absolute value. So you can occasionally will see something that looks like this. A number enclosed, instead of parentheses or anything like that, enclosed in two straight lines. It could be something, this would be read the absolute value of -5. Or you could have the absolute value of something like 8. Let's talk about what we mean by the absolute value. Once we understand what the absolute value stands for, then we can do equations that involve the absolute value. Now, in terms of numbers, the absolute value of a number is just what is the value of the number? Don't look at its sign. In other words, if you want the absolute value of a number, just drop its sign. So the absolute value of -5 is 5. The absolute value of 8 is 8, because 8 is really a +8, and if you drop its sign, you just get 8. Notice when you take the absolute value of a number, you always get a positive answer, because you're never going to have a negative sign in it. So your absolute value is always a positive number. what is the point of absolute value? Well, there is a geometric interpretation of absolute value that maybe will make sense to you. Let's say you have a number on the number line. Here's a number -5. It's right here. What if I ask this question? How far is that number from the origin? The origin is the starting place of all numbers, right? If I have the number -5, how far is it from the origin? How many steps do I have to take if I start over here to get to the origin? Well, it's obvious. Or how far is it from the origin to this number? The answer is it's 5 steps or 5 units. If I ask you, let's say here's number the 8. If I ask you how far is it from the origin to this number 8, you would tell me it's 8 units. What's the difference from the basic difference between this situation to this situation is over here, you're going to the left, and over here, you're going to the right. But how many steps you're going doesn't depend on whether you're going to left or right. It's just telling you how far you're going. So the sign is an indication of your direction. A positive sign means go to the right. A negative sign means go to the left. But the value of the number, the absolute value of the number is telling you actually how many steps you want to take. So that's what it means geometrically. When you're talking about the absolute value algebraically, you're just talking about what is the value of the number. Forget about its sign. When you're talking about it geometrically or graphically, you're talking about how far are you from the origin. And again, it doesn't matter which direction you're going because that's not what you're being asked. Okay, so I think everybody knows that really when you have an absolute value, all you have to do is drop the sign. There's not much more that you have to know about that. What happens when you have an equation that has an absolute value in it? So let's look at that. Let's start with a very simple equation. And from the solution to the simple equation, we'll get a method of solving more complicated examples. Okay, so let's say I had something like this. The absolute value of x is equal to 3. What's being said here is, I know what the absolute value of my number is. And what I want to know is, what was the original number? What was x before I took its absolute value? I know after I took its absolute value, I got 3. But what was the x before that? Well, if I think about it algebraically in terms of the numbers, there are 2 possibilities that x could be. X could originally have been 3, because certainly the absolute value of 3 is 3, or x could have been -3, because both of these numbers, when you take their absolute value, will give you 3. The absolute value of 3 is 3, the absolute value of -3 is 3. In other words, the solution to this equation is really 2 answers, 3 and -3, because both of those numbers have an absolute value of 3. If I could have interpreted it also given the number line. Here's my number line. What does it mean that the absolute value of x is 3? It means that the number on the number line that I'm looking for is 3 units from the origin. Now, how can I go 3 units from the origin? I can either go 3 units to the right, which will get me to +3, or I could have gone 3 units to the left, which would get me to -3. Both of these numbers are 3 steps away from the origin. So again, there are 2 answers to it. -3 and 3. So basically, what we have to know about an absolute value equation is that when we want to solve it, we really want to get 2 answers. Now, there's one thing that I really have to be careful about, and that's that when I have an absolute value equation, that the number that the absolute value is equal to is a positive number. In other words, if I were to have given you something like the absolute value of x is equal to -5, there would be no solution. You know this symbol, this is called the empty set or the null set. It means no solution. A 0 with a line crossing through it means no solution. You could just write no solution, because it's impossible for the absolute value to be a negative number. So now we're in a position to talk about solving more complicated situations that have absolute values in them. And I'm going to do one that's about as complicated as you could get. I mean, it's not going to be terribly complicated. The only thing that might make it more complicated is if it has fractions or decimals. But in terms of the solution of it, we're going to go through an example. Okay? So here, let's look at one. Suppose I give you an equation that looks like this. The absolute value of x minus 5 plus 3 equals 7. Let's say I gave you that example. And I ask you to solve this absolute value equation. Here's how you go about it. Step number 1, you want to isolate your absolute value. You want to get the absolute value all by itself. So if there's anything outside, something multiplying, something dividing, something adding or subtracting, first get rid of it. Now, the only thing that's outside this absolute value on this side is that 3. So the first thing I want to do is get the 3 to the other side. That'll give me that the absolute value of x minus 5 is equal to 4, because 7 minus 3 is 4. Okay, now I take a pause. Once I have the absolute value by itself, I look at the absolute value is equal to a number. This number that it's equal to has to be positive. If it's not positive, or it might be 0, but it can't be a negative number. If this is a negative number, I stop right there. There's no solution. It's impossible for the absolute value to be equal to a negative number. Well, in this case, it isn't equal to a negative number. It's equal to a positive number. In that case, I go further by separating this into 2 equations. One equation is simply x minus 5 equaling 4. In other words, I just drop the absolute value. And the other equation I get by doing x minus 5 equaling -4. Just like we did before, remember when we have the absolute value of x equaling a number, it could be either the positive number or the negative number. The same thing over here, even if there's more complicated things inside that absolute value sign, it could either equal to this positive number or it could equal that negative number. And that will leave you 2 equations. So in this equation, I'll add +5 to both sides and get one answer being x equaling 9. And again, I add 5 to both sides. And in this, I get x equaling 1. So your solution to this equation is 2. One answer is 1, one answer is 9. You could put your answers in braces, or you could just leave it like this. There are two answers. When you are solving an absolute value equation, you want to make sure you give both answers, because your answer could either be +9. Notice if this is +9, then 9 minus 5 is 4. The absolute value of 4 is 4, so 4 plus 3 is 7. And when x is 1, then this is 1 minus 5, which is -4, but the absolute value of -4 is also 4. And again, this 4 plus 3 gives you 7. So both answers work. And that's how we solve an absolute value equation. We take both, we simplify it so we have the absolute value by itself, and then we break it up into two equations. Okay, I'm going to give you one to try on your own. Okay. Let's say I gave you this example. The absolute value of 2x minus 8 plus 3 equals 2. Okay, I'm going to give you a few minutes to try that on your own. See, we're coming up with, some people are coming up with answers. I'll give you a couple more minutes. Okay, I see. Let's work on this together. Okay, I'm gonna erase this one. And I'm gonna bring that over to this side. Okay, we have the absolute value of 2x minus 8 plus 3 equals 2. Okay, so if I recall, our first step is to get the absolute value by itself, which means I want to get rid of this 3 over here. I'm going to do minus 3 from both sides, which will give me the absolute value of 2x minus 8 equals -1. And remember, this is where I pause and I think, can I go further? And I look at this number that's on the other side of the absolute value sign, and I see it's negative. And one person came up with that. There's no solution. Because it's impossible for the absolute value to be equal to a negative number. We don't go any further. We don't break it up into two. If this would have been a positive one, I would have broken it up into 2 equations. But I don't in this case because you cannot have the absolute value equaling a negative number. And I know that's a little bit of a trick, but I wanted you to make sure that you understood that this is what we have to do. Okay, I'm going, again, look out for homework on Delta Math. I'm going to continue on Thursday with this, and we'll just finish up this first chapter. We're going to be starting after that with linear equations, drawing equations on an X and Y axis. I'm sure you remember doing that, but we're going to review that and talk about solving things on graphing. Okay, have a good day. Does anybody have any questions they want to ask me before I end class? Any questions at all? Let me just mention that I am on before my first class, which starts at 10 o'clock. Between 9:15 and 10, I am on Zoom on this Zoom number, on this account. If you ever want to meet with me or talk about anything, about whether you want to get which calculators you have or anything of that nature, you can always either send me an email, or if you have a question that can be answered by the email, or if you want to meet with me in person, that is my office hours between 9:10 and 10, or between 9:15 and 10. It's always a good idea if you're going to meet with me just to let me know ahead of time, but I am usually right on the Zoom, so you can meet with me in person. I noticed in my other class that they were forming a WhatsApp group to work on things together as well. So that might be something that you might be interested in doing for this class as well. All right, I'm going to stop recording now.